With the cockpit clock just sliding past 0511 on November 22, 2025, a Russian Mi-8 AMTS-SH pushes through 120 meters of altitude west of Rostov-na-Donu and flies straight into an ambush it cannot see. For the last 30 minutes, it has been skimming 20-30 meters above frozen fields and riverbeds, using trees, warehouses, and low villages as cover. But a band of power lines and a raised highway force the pilot to pull, trading the safety of ground clutter for a short, 8-second climb through clean air. That extra climb is all the enemy needs. 15 kilometers away, a Ukrainian long-range strike drone is holding at roughly 600 meters. Engine throttled back, nose pointed into a designated kill box drawn on its mission computer. It left a makeshift launcher in eastern Ukraine at 0418, flew more than 400 kilometers across the front at low level, and arrived here a few minutes early to wait. For 2 weeks before this morning, Ukrainian analysts logged this helicopter's route, same corridor, same bend in the river, same rear area lane between Rostov and the front. Usually flown in a narrow window between 0340 and 0355. Those habits were turned into coordinates, time brackets, and a simple rule: if a Mi-8 appears in this box between 0509 and 0513, the drone will attack. Now, as the rotor disc of the climbing Mi-8 clears the tree line, a white-hot fuselage hardens in the drone's infrared sight. The timing, altitude, and position all match the numbers loaded in before launch. What used to be a routine shuttle flight in safe airspace has, in the span of a few seconds, become the closing move of a deep strike hunt above western Rostov. In the weeks before the engagement, Rostov-na-Donu functioned as a rear logistics node for Russian forces in eastern Ukraine. Units from the 4th Air and Air Defense Army and supporting ground formations pushed artillery ammunition, vehicle spares, drone components, and personnel through its rail yards and ring roads toward frontline groupings, roughly 200-250 kilometers away. On a typical day, several long trains and dozens of truck convoys fed this flow. Daily throughput is measured in several thousand tons of materiel. Planners counted pallets of ammunition, crates of spares, and fuel containers rather than individual vehicles. Rotary wing sorties filled gaps where roads and railheads had taken damage. On Russian planning maps, the city sat outside tube artillery range. In Ukrainian planning tools, it already lay inside a long-range strike geometry drawn by missiles and one-way drones, as fixed depots and bridges closer to the front absorbed more deep strikes. Russian staff officers shifted sensitive flows to rotary wing lift under Army aviation control. Mi-8 AMTS-SH and Mi-17 helicopters from a mixed helicopter regiment near Rostov ran rear-area shuttle flights along low-level corridors. Each night, 4 to 6 sorties out of the same pads moved staff officers, encrypted communications gear, stabilized optics, and sealed containers that were not supposed to sit on exposed rail spurs. Typical leg length for these shuttles ran 120-160 kilometers. Most legs carried between 2 and 4 metric tons of cargo, or up to 24 passengers. Depending on configuration, flight orders emphasize terrain masking and minimum exposure, stay in ground clutter, and avoid clean climbs that would give higher radar tiers a stable track. Within that traffic pattern, one route west of Rostov generated repeat data over nearly 2 weeks. On most days between 0340 and 0355 Moscow time, a Mi-8 AMTCH lifted from the same military strip north of the city. Departure times across 10 recorded mornings fell inside a narrow band between 0342 and 0353. The helicopter turned onto a known departure line and descended into a low corridor at roughly 20-30 meters above ground level. From there, it tracked along a river bend before cutting toward the front. The flight fell out of radar coverage almost immediately and only reappeared briefly when local terrain forced it to climb. Timestamps from several mornings lined up within a few minutes of one another along the same section of airspace. Across those passes, the route trace varied by less than 1 kilometer laterally at the forced climb segment. Initial detection on the Ukrainian side remained fragmentary. A long-range radar under Air Force control, with a range fan reaching deep into the Rostov region, recorded a slow, low-altitude return appearing and disappearing in the same time band across multiple days. Track quality stayed low. The radar's rotation period sat in the single-digit seconds, yielding only 1 or 2 clean sweeps on each flight. Clutter maps are updated continuously as ground returns shift with temperature and humidity. The signature entered the display, dipped into clutter, and dropped. Civil channels produced indirect indicators when reports of rotor noise and low helicopter passes west of Rostov lined up with the same pre-dawn window. By the end of the second week, the pattern of activity between roughly 0340 and 0430 Moscow time was no longer treated as noise. Inside a buried Ukrainian command node supporting a long-range strike cell, analysts flagged the return as a candidate pattern and began to build a digital fire control picture around it. Each day, the Mi-8 appeared. They logged estimated wheels uptime, initial heading, and the approximate point where the track disappeared. They overlaid commercial imagery of the Rostov outskirts and marked a river bend, a highway rise, and a line of pylons along the route. Previous passes were replayed on a synchronized timeline. Estimated positions at 10, 20, and 40 minutes after takeoff sat on top of one another within a narrow corridor west of the city. The area was broken into grid squares 1 kilometer on a side, each tagged with time and confidence values. Overlays from different days were stacked into a 3-dimensional pattern of where and when the Mi-8 had been. A simple constraint emerged. The Mi-8 left the strip, dropped into the low corridor, then faced one unavoidable requirement west of the city. The combination of river bend, highway rise, and pylons forced a short climb from 20-30 meters AGL toward 100-140 meters AGL. That forced climb, 8 to 10 seconds long, exposed the helicopter above clutter and produced a clean rotor disc signature. On the composite timeline, that climb repeated in almost the same place and within the same minute of flight time on each recorded day. Once the constraint held across multiple mornings, the command node moved from observation to pre-computation. Operators defined a rectangular kill box 3x 4 kilometers around the forced climb area. The box aligned with the river bend, highway rise, and pylons and enclosed the expected ground track. They drew entry and exit lines for the Mi-8 and set a time bracket 05090513 based on previous passes and estimated cruise speed between 180 and 210 kilometers per hour. Within that geometry, the climb window became a fixed feature. If the helicopter launched in the usual 0340-0355 band, it would cross the box in that 4-minute window. The weapon selected for the intercept was a long-range WarZoneX one-way strike drone controlled by the same cell. It carried a 20-30 kilogram high-explosive fragmentation warhead and cruised between 150 and 200 kilometers per hour. Navigation used combined GNSS and inertial data with cross-checks against preloaded terrain elevation. The expected navigation error at the box was held under 100 meters. It was configured to execute a racetrack loiter 600 plus 50 AGL over the box. Mission planners programmed a route from an improvised launch site in eastern Ukraine to the intercept area and left margin to arrive on station 2 to 3 minutes before the earliest expected entry into the bracket. On the planning board, the sequence is compressed into 5 markers: a 0340-0355 launch window for the Mi-8 0418 for the drone, a border crossing just after 0430, an on-station time near 0506, and an expected climb through the box a few seconds either side of 0510. In the mission planning software, the road appeared as a sequence of waypoints that skirted known Russian radar sites and air defense belts, including Buk M2 and S-300 batteries further inland. The time profile supported a launch at 0418 and a frontline crossing a few minutes later. It also allowed transit of more than 400 kilometers before the drone reached the box. The same tool showed estimated crossing time into Russian airspace near 0430 and arrival in the wider intercept area just after 0500. Inside the command node, the digital fire control picture fused the planned track with the pre-computed geometry, the bracket, and the climb window. Tolerances for timing and cross-track error were set in hundreds of meters and tens of seconds. Ground crew at the launch site ran a short checklist in the last minutes before 0418 Kyiv time. Fuel quantity, control surface response, data link health, navigation alignment, and warhead safing each received a discrete confirmation. Fuel margin was thin but sufficient for transit, loiter, and one attack run. Clamps released on time. The drone left the rail, climbed through its initial vulnerable minute, then descended into low-level cruise to exploit terrain masking along the route. Cruise speed stabilized in the 160-180 km/h band. Russian sensors generated only intermittent low-altitude returns as the airframe moved along its path. Tracks broke in the clutter. Valley glare and background suppression filters washed out small, low targets. No fire control channel opened. No operator saw a stable inbound track. On the Ukrainian side, telemetry updated position, speed, and altitude into the command node in short bursts. Update intervals ran on the order of 1 to 2 seconds. The time tag showed the airframe crossing the front line in the first minutes after 0430. Link latency climbed toward a few hundred milliseconds, but stayed within tolerances. On the map, the drone's movement is held as a clean, plotted line just outside threat range as the drone approached the intercept area. Guidance commanded a climb to the loiter altitude, around 0506 on the command node clock. It leveled near 600 meters AGL and reduced speed toward the lower bound of its cruise band to limit overshoot. The airframe turned into a racetrack pattern that sat entirely inside the box. One orbit, then another, kept the sensor footprint centered on the obstacle set that had defined the forced climb. On each leg, the sensor swept through the climb window and then back across the low corridor. The screen stays flat. The box shows only terrain. Traffic on the highway paints as narrow, low streaks. The tracking gate ignores them. Track quality remains low. Fuel count ticks down. The clock rolls past 0508. One more circuit, and the bracket begins to close. On the next sweep, heat blooms where the map has stayed empty. A single hot patch rises over the obstacle set. The system flags a new source in the climb band. Rotor halo forms around the engine core. The lock gate closes. The range gate begins to step down. The range sits near 700 meters. Time to target reads 12 seconds. Closure rate holds around 58 meters per second. On the command node display, the return resolves into a track and snaps onto the pre-computed path through the box. Speed matches the Mi-8 profile in the climb window. Climb rate matches the modeled profile from the low corridor into the climb band. Entry time falls inside the bracket. Command node time reads a few seconds past 0510. Fuel remaining under 4 minutes. One more orbit and the time window closes. No chance for a second attack run, signature, geometry, and timing align. Range gate stays stable. The fire solution is confirmed. Fire command goes out on the link. Speed drops 12 kilometers per hour. Bank angle shifts 8 degrees. Nose lowers 2 degrees. From the helicopter, the maneuver stays inside normal parameters. An obstacle clearance over the obstacle set. Collective input increases. The airframe moves up through the climb window. Russian surface wave and low-level radars still produce only intermittent low-altitude returns. Tracks break in clutter. No fire control channel forms on the inbound drone. On the drone feed, the Mi-8 fills the frame. Rotor halo stays sharp. Range closes fast. Link delay grows, but telemetry stays usable. The crossing solution holds. At the preset distance, the warhead fuse arms. The range reads 400 meters. Time to impact reads 8 seconds. The airframe cuts across the climb path. The warhead detonates near the upper fuselage. The frame goes white. Signal cuts. Range and heat collapse into noise. Telemetry from the drone stops almost at once after detonation, as planned. The command node display drops the outbound track and holds the target. The Mi-8 core signature elongates, rotates, and then fragments into smaller heat sources. They track along a short, unstable ground path and then fix in place west of the obstacle set as the airframe and major components settle. Primary heat source drops under tracking threshold. Secondary sources fade below the sensor floor. Impact is confirmed. Target is flagged lost. Coordinates are stored in the log. The combat box closes. System status reads nominal. No further tracks appear in the area. Inside the Ukrainian command node, the engagement over Rostov closes as a short entry. One Mi-8 AMTSH was destroyed inside the rectangular kill box. Impact time logged a little after 0511 on the 22nd of November 2025. Coordinates stored with accuracy in the tens of meters. The strike drone was recorded as expended as designed. Cost line 1, long-range one-way airframe and warhead traded for a fully crewed multi-role helicopter and its load. On the Russian side, the same event appears first as a loss of contact message, then as a crash report from local authorities west of Rostov. Army Aviation and the 4th Air and Air Defense Army register a Mi-8 down in rear airspace between 0515 and 0530. Initial notes cite probable technical failure. Later inspection of the wreckage, blast effects near the transmission area, and fragment patterns shift the cause into the external strike column. Once classified as a combat loss, the route that fed the pattern is dismantled. Departure times for rear area helicopters are spread instead of clustered in the same pre-dawn window. Standard legs along the river bend and highway rise near the old box are removed or pushed higher in the climb band. Additional sorties carry self-defense pods or run closer to short-range air defense belts. Lift once reserved for cargo now pays for survivability. For the Ukrainian strike cell, the event is treated as a worked example. A repeat shuttle in the 0340-0355 window, a forced climb 8 to 10 seconds long, and a time bracket 0509-0513 proved enough to anchor a kill geometry more than 400 kilometers from launch. The same method pattern, constraint, bracket, box can be applied to other rotary or transport flows that show similar habits. The loss of one Mi-8 west of Rostov alters what both sides call rear airspace. Russian crews now have to assume that their flight times and climb profiles may be recorded and turned into intercept boxes. Ukrainian planners know that any long-range drone profile they use can be studied and countered on later nights. In the log, the sequence ends as a string of states detected: tracked, engaged, closed. In the wider system, it removes a tested route and forces new calculations on where it is safe to fly and where it is not.